All right, so today we're looking at something pretty special. It's just a single sheet of paper, but it's hiding a really beautiful message. You see, this is a piece of math that's so much more than just numbers and symbols. It's basically a greeting card in disguise. I know, it sounds a little crazy, right? Calculus. That's all about rates of change and areas under curves. It's not exactly what you'd call festive. But what if it could be? What if you could take a complex equation and have it actually spell out a warm holiday message? So here's the thing. We're actually going to start at the end, just to reveal the punchline. The final line of this entire long calculation is simply Eid plus Mubarak. That's it. A lovely holiday greeting. But the real magic, the real question is, how on earth does a ridiculously complex integral boil down to this? Let's figure it out. Okay, so to unpack this whole thing, we got to go back to the beginning. And I'll be honest, when you first look at this problem, it is pretty intimidating. And here it is in all its glory. It's a definite integral with some pretty strange limits, going from e to the power of negative Mubarak all the way up to e to the power of Eid. But the real star of the show is that monster of a denominator, an infinite series of nested square roots. I mean, it just looks like a total mess. You know, the real key to this whole thing, it's all hiding right there in that denominator. If we can just figure out what's going on with that part, the rest of this puzzle might just click into place. That crazy nested square root, that's the lock we have to pick. And this is where things get really fun. This isn't just about crunching numbers. This is about solving a super clever puzzle that someone very carefully designed. So how do we tame this beast? I mean, look at it. An infinite series of square roots. It looks totally impossible to calculate directly. But, and this is the cool part, there's this incredibly neat and elegant trick that we can use. So check this out. First, we just take that whole infinite mess and we give it a simple name. Let's call it y. Now here's the really clever part. Because those roots go on forever, if you look inside the very first square root, what do you see? You see the exact same infinite expression all over again, which, remember, we just called y. So that whole equation simplifies down to y equals the square root of x times y. From there, it's just a little bit of algebra. You square both sides, you divide by y, and all of a sudden you're left with this shockingly simple answer. Y just equals x. I mean, seriously, can you believe that? That whole monster of an expression, all that scary-looking infinite math, it just melts away and becomes x. That's it. That was the key we needed to unlock this whole problem. Okay, so now that we've tamed the beast in the denominator, we can put it all back together and finally solve this thing. So you remember that messy denominator? We just proved that the infinite nested part simplifies to x. And this is where you really appreciate the genius behind this problem. The whole thing was built so that after you do all that work, the entire denominator becomes just x. So our once terrifying integral is now something much, much friendlier. Just the integral of dx over x. Okay, time for the calculus bit. And don't worry, it's a real classic. The integral of 1 over x is one of the first things you learn in a calculus class. It's the natural logarithm of x, or ln of x. It's just a fundamental piece of the puzzle. All right, so we take our solution, ln of x, and now all we have to do is plug in those weird-looking limits from the very beginning. The upper limit, e to the power of Eid, and the lower limit, e to the power of negative Mubarak. And this is the second big aha moment of the whole problem. You see, the natural log, ln, and that exponential function e, they're inverses of each other. They basically cancel each other out. It's kind of like adding 5 and then immediately subtracting 5. So the natural log of e to the Eid is just Eid. And the natural log of e to the negative Mubarak is just negative Mubarak. Now, you might remember from calculus, when you solve a definite integral, you take the top limit's result and you subtract the bottom limit's result. So what we get is Eid minus negative Mubarak. And of course, subtracting a negative number, that's the same thing as adding a positive. And there it is. Eid plus Mubarak, that whole complicated mess, it was all just a beautiful, elegant setup for a simple, warm-hearted holiday greeting. Just incredible. So what's the big takeaway here? You know, when you see something like this, it makes you realize it's so much more than just a clever math problem. It's almost like a piece of mathematical poetry. What this one little equation really shows us is that math isn't just about rigid rules and boring calculations. It's a genuinely creative language. You can use it to tell jokes, to create art, to hide these wonderful messages. And it's such a powerful reminder that even the most intimidating, complex-looking problems can have these incredibly simple, elegant solutions. And you know what? Sometimes the journey of figuring it all out is just as interesting as the answer itself. It really makes you wonder, doesn't it? If someone can encode a holiday greeting in a calculus problem, what other secrets, what other jokes and beautiful ideas are just waiting out there to be discovered inside the language of numbers? It makes you think, what else might we find if we start looking at equations not just as problems to be solved, but as stories to be read?